Welcome back to Tech Cloud Solutions, Part 9 of AZ-104. Last time we crushed network security groups. Today, 5 brutal questions on Microsoft Entra ID, subscription, and many more that trip up 70% of test takers. Let's dominate this. Question 51. You have an Azure subscription that contains 3 virtual machines named VM1, VM2, and VM3. All the virtual machines are in an availability set named AVSet1. You need to scale up VM1 to a new virtual machine size, but the intended size is unavailable. What should you do first? This question is about what to do when you can't resize a VM because the desired size isn't available on the current hardware cluster. The key phrase is the intended size is unavailable. This means Azure needs to move the VM to a different hardware cluster that supports that size. The options are A, create a proximity placement group, B, deallocate VM1, C, convert vset1 into a managed availability set, D, shut down VM2 and VM3. Think of it like trying to upgrade your seat on a fully booked flight. The airline needs you to get off the plane first before they can move you to a different flight with better seats available. Azure works similarly. If the new VM size isn't available on the current hardware cluster, you must deallocate, fully stop the VM so Azure can move it to a compatible cluster. Correct answer, B, deallocate VM1. When a VM size is unavailable on the current hardware cluster, you must deallocate VM1 first. Deallocation is necessary because Azure cannot move a running VM to a different hardware cluster that supports the new size. Here's what happens. When you deallocate VM1, Azure fully releases the compute resources and gives itself the flexibility to reallocate the VM to a different hardware cluster where the desired size is available. Simply stopping the VM isn't enough. You need full deallocation, which shows stopped deallocated status in the portal. After deallocation, Azure can place VM1 on compatible hardware, complete the resize operation, and then you can restart it with the new size. Why the other options are incorrect? A, create a proximity placement group. This groups VMs together on the same hardware for low latency, but doesn't solve the hardware cluster availability issue for resizing. C, convert AVSet1 into a managed availability set. Availability sets are already managed in modern Azure. This action doesn't exist and wouldn't help with VM sizing availability. D, shut down VM2 and VM3. Deallocating other VMs in the availability set isn't necessary. You only need to deallocate the specific VM you're resizing, VM1. The other VMs can keep running. Quick takeaway, intended VM size unavailable equals deallocate that specific VM first. This lets Azure move it to a hardware cluster that supports the new size. If this video is helping you, support us by hitting the like button, and don't forget to subscribe for more content like this. Question 52. You have an Azure subscription that contains the resources shown in the following table. You create a public IP address named IP1. Which 2 resources can you associate to IP1? This question tests your knowledge of which Azure resources can directly have a public IP address attached to them. You need to identify the 2 resource types where you can attach a public IP address at the Azure configuration level. The options are A, VM1B, LB1C, NIC1, D, VPN1, E, VNet1. Think of a public IP address like a street address for your house. You can attach it to specific entry points like your front door, NIC, or mailbox cluster, load balancer, but not to the entire neighborhood, VNet, or the land itself. Public IPs need a specific connection point, not abstract groupings or containers. Correct answer, B, LB1. C, NI1 public IP addresses in Azure can be directly associated with load balancers, LB1, and network interface card to 1. These are the 2 correct answers. Here's why these work. A load balancer uses a public IP as its front-end IP configuration, which becomes the internet-facing endpoint for distributing traffic to back-end pool members. This is the most common use case for public IPs with load balancers. A network interface card, NIC, attached to a virtual machine can have a public IP directly associated with it, giving that specific VM direct internet connectivity. When you attach a public IP to a NIC, the VM gets its own public-facing address independent of any load balancer. Why the other options are incorrect? A, VM1, virtual machine. You don't attach public IPs directly to VMs. Instead, you attach them to the VM's network interface card, which is then connected to the VM. The NIC is the actual attachment point. D. VPN1, Virtual Network Gateway. While VPN gateways do use public IP addresses for VPN connections, they're typically configured during gateway creation and use specific gateway type public IPs, not general purpose public IPs you create separately. E. VNet1, Virtual Network. Virtual networks are logical address spaces and cannot have public IPs directly associated with them. Public IPs are assigned to resources within the VNet, like NICs or load balancers, not to the VNet itself. Quick takeaway: public IP addresses go on load balancers for front-end traffic distribution and network interface cards for direct VM internet access. Remember, NICs are the connection point for VMs, not the VMs themselves. To get the free PDF or mock test, comment PDF or mock or both. I will share the downloadable link within the next 24 hours. Question 53. You have an Azure subscription that contains two peered virtual networks named VNet1 and VNet2. VNet1 has a VPN gateway that uses static routing. The on-premises network has a VPN connection that uses the VPN gateway of VNet1. You need to configure access for users on the on-premises network to connect to a virtual machine on VNet2. The solution must minimize costs. Which type of connectivity should you use? This question tests your understanding of VNet peering limitations and how to enable on-premises networks to reach peered virtual networks through an existing VPN gateway. The key challenge is that VNet peering is non-transitive, so traffic from on-premises through VNet1's gateway cannot automatically reach VNet2 without additional configuration. The options are A. Azure Firewall with a private IP address. B. Service chaining and user-defined routes, UDRs. C. Azure Application Gateway D. Express route circuits to VNet2. Think of it like a highway toll system. Your on-premises network has a toll pass for the highway to VNet1, but VNet2 is on a side road that's not included in your pass by default. Service chaining is like adding direction signs, UDRs, that tell traffic to reach VNet2. Use the VPN gateway in VNet1 as your next hop, using existing infrastructure without building new expensive roads. Correct answer: B. Service chaining and user-defined routes, UDRs. Service chaining with user-defined routes, UDRs, is the correct and most cost-effective solution to enable on-premises users to access VNet2 through VNet1's existing VPN gateway. Here's why this works. VNet peering is non-transitive, meaning when VNet1 peers with VNet2, traffic from on-premises connected to VNet1's gateway cannot automatically reach VNet2. Service chaining solves this by using UDRs to direct traffic from VNet2 through VNet1's VPN gateway as the next hop. You configure a UDR in VNet2 that specifies the VPN gateway in VNet1 as the next hop for on-premises address ranges. This creates a hub-and-spoke architecture where VNet1 acts as the hub with the VPN gateway, and VNet2 is the spoke accessing on-premises resources through gateway transit. This is the most cost-effective solution because you're reusing the existing VPN gateway infrastructure in VNet1 instead of deploying additional gateways or expensive services. UDRs and service chaining have no additional costs. You only pay for the existing VPN gateway you already have. Why the other options are incorrect. A. Azure Firewall with a private IP address. While Azure Firewall can route traffic, it's an expensive managed service, costs hundreds of dollars per month, and completely unnecessary for this simple routing requirement. It doesn't minimize costs. C. Azure Application Gateway. This is a Layer 7 load balancer for web applications, not a networking connectivity solution. It cannot route VPN traffic from on-premises to VNet2. D. Express route circuits to VNet2. Express route is extremely expensive, thousands of dollars per month, and completely overkill for this scenario. You already have a working VPN connection. There's no need to deploy express route. Quick takeaway: on-premises to peered VNet through existing gateway equals service chaining with UDRs. Configure routes in VNet2 pointing to VNet1's VPN gateway as next hop. Zero additional cost, maximum efficiency. Question 54. You have an Azure subscription that contains a storage account named Storage One. You need to ensure that the access keys for Storage One rotate automatically. What should you configure? This question tests your knowledge of which Azure service provides automatic rotation capabilities for storage account access keys. You need to identify the security service specifically designed to manage, store, and automatically rotate secrets and keys. The options are A. A backup vault. B. Redundancy for Storage One. C. Lifecycle management for storage 1. D. An Azure Key Vault. E. A Recovery Services Vault. Think of access keys like house keys. Leaving them unchanged forever is risky. You need a smart key management system that automatically changes your locks on a schedule. Azure Key Vault is that management system, automatically generating new keys and updating them without manual intervention. Correct answer, D, an Azure Key Vault. To enable automatic rotation of storage account access keys, you need to configure Azure Key Vault. Here's how it works. You integrate your storage account with Azure Key Vault by navigating to your storage account's Access Keys section and clicking Connect to Key Vault. Then you select your Key Vault and choose a secret to store the access keys. Once connected, you configure an automatic key rotation policy in Key Vault that defines the rotation schedule, daily, weekly, monthly, or custom intervals. Key Vault manages the rotation process by publishing near expiry events to Event Grid, which triggers an Azure function that regenerates the alternate key, switching between Key 1 and Key 2, and stores the new key as a new version of the secret. You can also use Azure CLI to set this up with commands like AZ Key Vault Storage Add with -auto regenerate key parameter and specify regeneration periods like P1D for daily rotation. Why the other options are incorrect. A backup vault. This is for Azure backup operations to protect data, not for managing or rotating authentication keys. B, redundancy for storage 1. This configures data replication, LRS, GRS, ZRS for disaster recovery, not key rotation or security management. C, lifecycle management for storage 1. This manages data lifecycle policies, moving data between access tiers or deleting old data, not access key rotation. E, a recovery services vault. This is for backup and disaster recovery services, not secret or key management. Quick takeaway. Automatic key rotation equals Azure Key Vault. Connect your storage account to Key Vault, set a rotation policy, and let it automatically regenerate keys on your schedule for enhanced security. Question 55. You have a Microsoft Entra tenant. You plan to perform a bulk import of users. You need to ensure that imported user objects are added automatically as the members of a specific group based on each user's department. The solution must minimize administrative effort. Which two actions should you perform? This question tests your knowledge of how to efficiently bulk import users into Microsoft Entra ID and automatically assign them to groups based on their attributes, like department, with minimal manual work. You need to identify the right file format for bulk import and the right group type that automatically manages membership based on user properties. The options are A, create groups that use the assigned membership type. B, create an Azure Resource Manager ARM template. C, create groups that use the dynamic user membership type. D, write a PowerShell script that parses an import file. E, create an XML file that contains user information and the appropriate attributes. F, create a CSV file that contains user information and the appropriate attributes. Think of it like organizing students into class sections automatically based on their major. You want the system to read each student's major from a spreadsheet and place them in the right class without manual sorting. Dynamic groups work like smart filters that automatically include users who match specific criteria, like department engineering. And CSV files are the standard way Microsoft Entra accepts bulk user data. Correct answer, C. Create groups that use the dynamic user membership type. F. Create a CSV file that contains user information and the appropriate attributes. To bulk import users and automatically assign them to groups based on department with minimal administrative effort, you need to use dynamic user membership groups and a CSV file containing user information. Here's why this combination works. Microsoft Entra ID supports bulk user creation through CSV, comma-separated values files, that you download as a template from the Admin Center. The CSV template includes fields like user principal name, display name, department, job title, and other attributes. When you fill in the department field for each user in the CSV and upload it, Microsoft Entra creates the users with those department attributes populated. Then, dynamic user membership groups automatically manage group membership based on rules you define. For example, you create a dynamic group with a rule like user.department-EQ engineering, and all users with engineering in their department attribute are automatically added. When new users are imported with department information, dynamic groups evaluate their attributes and add them automatically. Zero manual effort after initial setup. This is the most efficient solution because group membership is maintained automatically as user attributes change. Why the other options are incorrect. A. Assigned membership type. These are manual groups where you must explicitly add each member. This requires significant administrative effort and defeats the purpose of automation. B. Azure Resource Manager, ARM template. ARM templates deploy Azure infrastructure resources, not user accounts in Microsoft Entra ID. Wrong tool for the job. D. Write a PowerShell script. While possible, this adds unnecessary complexity and ongoing maintenance. Dynamic groups to CSV is the native, simpler solution that minimizes effort. E. Create an XML file. Microsoft Entra bulk operations don't use XML format. The standard and supported format is CSV files. Quick takeaway. Bulk user import equals CSV file, Microsoft standard format. Automatic group assignment by department equals dynamic user membership groups with attribute-based rules. Together, they give you zero-touch group management.